All right, welcome back to Blueprint Reading, Section 3, Unit 1, Understanding Prints, Engineering Drawings. We just talked a minute ago, we finished up. We're going to continue on about section views, cutting plane line, and section views. Okay, so we talked a little bit ago about assembly drawings. This top left drawing right here shows basically two pieces that could be put together. Very similar to the three steps. If one top half were there, bottom right half were there. It's not exactly what it's depicting, but you can see that from this drawing. It's not just an assembly line. Main thing I wanted to show you on this is down here on the bottom left is the section view. So it's showing you a cross-cut section. Okay, showing you that that's the internal pieces instead of showing the whole your center holes as all hidden lines. They're basically what they're saying is they cut it where the holes are, so you can get a clear depiction of what each one of these should look like. Okay. As you can tell, they're different colors. This one has a bushing in it, brass bushing in it as well. Okay. Anything you want to add on this one, Dan?
No.
I want to talk just a little bit. We've talked a lot about math, correct? So real quick, let's look at this detailed view here on this section. So right here it's given us our dimension line off of our extension lines. Our dimensions are 3750 to 3755, okay? And it's given us an outside dimension. Now our internal dimension is 0.250. So as you can tell, naturally we're going to have to figure out what the difference of that is. So it ends up being 0.125. But we're dealing with a circle, a round hole. So we know what the subtraction of both diameters are. But if we're looking at the thickness of this, we know it's 0.125. But if we're looking at the wall thickness, we're going to have to split that in half again because we have two pieces. So this wall thickness might be, it's half of the 125, it's 0.6250. Okay, 0.06250, sorry. So as we talk about the math, here's where it starts to come into play. We're going to have to be able to deduct this from this to figure out the wall thickness and on the bushing and so forth. Okay. All right, basic symbols and notation. Symbols and notation keep drawings from becoming too cluttered. Signify diameters, radii, drilled holes, countersinks, counterbores, depths, typical dimensions, TYP. These are something that I would definitely make sure you understand the symbols for all of these. What's the diameter symbol? What's the radii symbol? Holes, countersink, counterbore, depths, and typical dimensions, TYP. You really need to read through this paragraph, this entire paragraph on page 211 underneath basic symbols and notation. It's going to explain to you about typical dimension lines, what the abbreviation TYP means, the abbreviation EQL-SP, equally spaced. We hit that up on the last video when we were talking about three holes that are equally spaced across them, knowing it's 360 degrees, so they're 120 degrees each, so forth. Tolerance. Allowable variation from a given size. As you can see, there's a lot of different variations within tolerances, whether it's bilateral, unilateral, max material condition, and limited material condition, local, specified, and unspecified tolerances, so forth, okay? So here's a good breakdown to start with. I'm going to talk about radii, radius portion as well. We talked about this in the last one as also. So you can see the radius is 0.62. Now if we carried that out one more, it'd be 625. It also tells us that the top diameter of that hole, or the outside diameter of that radius, would be 1.25, just cut in half, right? The easiest way to think about it sometimes is, okay, so here's my radius, let's multiply it times 2, we'll know what the outside diameter of something is, work at it from that point. Let's see where we are as far as our zoom. Go down to the next left, we'll talk about the counter bore. You can see the symbol there. Okay. So the top section says diameter 0.50 through. So what in the world does through mean? Let's look at the bottom. So that means it's drilled the entire depth all the way through the part. Okay, it doesn't give you a depth. It's telling you it's drilled all the way through. Step down, now we have the counterbore symbol, a diameter of 1.12 with a depth symbol of 0.19. So what that's telling us is this entire section here is ½ inch, 0.500. Hole drilled all the way through, okay? There's no depth to it whatsoever. But when it comes time to the counterbore, the outside counterbore has a diameter of 1.12. So again, we're going to break that down half and half. If we were to do that, we'd be at 0.560, okay? Our depth means that we're going to be down 0.19 inches, all right? So if we had a tolerance zone there of 10 thousandths, we could be plus or minus 0.01, we could be 0.20 or 0.18, all right? But that's all it's telling us, is this is the depth, this is the diameter, and then of course the top one was drilled all the way through. Bottom left-hand one, very similar to the same thing. Just a countersink symbol, ½ inch. Now you can see this one, it doesn't go all the way through. Okay? ½ inch diameter, our countersink symbol, the diameter is 0.180. Okay? 90 degrees, so our included angle is 90 degrees here. All right? Let's look at this one. Same thing. This one gives us a depth. ½ inch drill times 0.56 deep, 0.181 diameter, 90 degree countersink, or it can be represented in this fashion as well. So what's the difference on this one? The T is just through. It's not through, but it's down 0.15 or 0.56. Okay? All right, finish all over. So when we are doing a surface finish, this symbol, that check symbol, basically is talking about our surface finish. We measure surface finish by micro inches. It's saying that finish all over 32 micro inches max. Finish all over 32 micro inches. It may be grind them all. 32, the micro inches symbol as well, finish max. Excuse me. All right. So we come to the top right hand section of this. Our radius is 3/16, typical. Over here is another example just to be able to know our symbols and notations. So if you see right here, you have 5 times the diameter of 0.250. So that means that there are 1, 2, 3, 4, 5 holes. They are all 1/4 inch diameter. Now if you look at the bottom left hand symbol, it shows you that the distance from outside to the center is 1/4 inch for your starter one. Then your pitch from hole to hole is 0.500. That's typical for all 5 or the rest of the holes, the remainder. Okay? Eight times diameter, 3/8 inch, equally spaced. So what can we denote from this print itself? We can see this is representing right-hand sections, so 90 degrees. If they're equally spaced, all of them, we know they have to be on 45 degrees as well. 8 divided by 360, it's going to be 45. Okay? I'm going to take a break, come back here in a few.